Sometimes some of the simplest possible things can cause major problems, and unit testing in software development is one such thing. That's why it's of utmost importance for developers as well as non developers alike to understand what exactly is meant by unit testing and what are the constructs that are available to them and how they can make use of the same. So welcome everyone to this particular video where we are going to talk about unit testing, why we are doing it, and what are the three most important things one should know about unit testing, and those three things are mocks, fakes, and stubs. We are going to do this in a generic way, which means I'm not going to show you any code but explain the concepts in such a way so that each and every one of you can understand it. So let's go ahead and start. Let's talk about unit testing. So first thing is why? Why we need unit testing? Now think about software. You cannot touch, smell, or feel the software to ascertain the quality of the software. It's not physical. You cannot have a physical verification of the software, and that's why you need to write test cases. Because tests are the only thing which can validate and verify the quality as well as the functionality of the software. Since tests are the only way, you need to make sure that each and every unit of the code, unit of the software written to support some functionality needs to be tested. And that's why unit testing plays a pivotal role in ascertaining the quality of the software. So, there are some misconceptions about the unit testing. Let's get rid of this misconception because this is going to prevent you from writing appropriate and better unit test cases. The misconception is that we are writing unit test to find the bugs in the code. No, that's not the case. That's the byproduct. The actual reason of writing unit test is to validate and verify the functionality of the software. And if you find bugs in there, you go ahead, fix that. But the main intention of unit testing is to understand and make sure the intended functionality is working. So that is the purpose of unit testing. Okay. Now, before going ahead, we need to understand what is the meaning of unit. What can be considered as a unit? Now, there are many companies which has some definition of it, like small function, this many lines of code. But I will recommend you to not to bind yourself with any such definition, because what is a unit depends upon individual programmers and the person writing the code. And once you are experienced with the way you are writing your code and acquainted with the system, the size of unit may grow, and there is nothing wrong in this. So the definition of unit depends upon individual developers. Just like in mathematics, you can give your answer in kilometer per hour or meter per hour. The answer will not be incorrect, just that the unit has changed. Okay, so let's move forward. Sometimes we have been asked to define the unit test cases. What is the meaning of unit test? So, you know what is the definition of unit? It depends upon individual developers. The idea of unit test is that to test that particular unit irrespective of its size. And that unit test must be able to run independently and should complete within milliseconds. Okay, so it's an independent piece of code which can be executed anytime without any dependency and should complete within the smallest possible time, possibly within milliseconds. Now, when we talk about independence of unit test, this is one place where many people ask lots of questions, and those questions are valid questions. Most often than not, the codes that are written, they are not, purely independent. They are dependent on many other things. The modules are dependent on other modules. Okay. And this is the place where things like test doubles comes into picture. Things like mocks, fakes, and stubs. Okay. So these are the entities or the constructs which helps us to validate the definition of a unit test which we have just seen. Independent, run within milliseconds. Let's go and see more about it. Okay, so in this picture on your screen right now, you can see that there are databases, there are APIs, there are network connections, and there are libraries. The source code, the production code in production environment will directly go and connect to those databases, APIs, libraries, and network sockets. But using the mocks, fakes, and stubs, we can do unit testing by connecting it to the mocking entity, faking entity, and stubbing entity, which will behave pretty much similar to what the actual system will do. But there are some differences between these three, which we are going to look into. But the idea is that when you are testing, you don't need to connect to real world APIs all the time because it might be costly, and any problem that might happen may cause a major outage. That's why it's of utmost importance that whenever we are testing, we have at least some set of mocks, fakes, and stubs to be able to test our system before it can be running using the production system. So let's first talk about mocks. What are mocks? As you can see in your screen, mocks are not intended for testing the functionality but the behavior of the system under test. So assume that your production code connects to Google API, maybe a Google Map API or something similar. Okay. Now you need to test it. So you create a mock, which means you have created a mock google.com or maps.google.com API. Okay. So now what is the meaning of mock over here? Mock means we are checking the behavior that I'm able to connect to an API and get the response. There will be a dummy response, but it is not intended to give you all the permutation combination of accurate geo coordinates or nearby geo coordinates or distance between two things. No, mocks are not for that. Mocks are mainly intended for verifying and validating the behaviors like, whether the application is running successfully or not, whether the API gets called, and in your application how many times this API gets called in your flow of all the work you are doing in your application. If you want to test these kind of things, you create mocks. Okay, now I hope that the concept of mocks are clear. Let's talk about stubs. Stubs are nothing but some of the entities which can generate predefined outputs, which means that if you want to connect to, again, let's say google.com API or maps.google.com API, you should be able to check what will be your response if you get a null response or a valid response or invalid response, or for example the server is not reachable. All those things you can check using stubs, and you create stubs to make sure that you are checking different paths of execution within your software, and that is the purpose of stubs. So I hope this is also clear. Let's talk about fakes. Now, before I go ahead and talk about fakes, let me tell you that most often than not, if you are creating some amount of mocks and stubs, you should be able to test your software to a large extent, to an extent where you can be comfortable with the validity and verification of your functionality. Now, fakes are one step ahead. Fakes are very similar to, it's kind of a local simulator so that they can replicate the near real world scenarios. So, fakes are nothing but they are simulators and they can simulate many behaviors. For example, They can simulate your REST endpoints, and as you can see in your screen, like they can actually simulate database connection, and if there is a delay in database connection, how the database will behave with less indexing or lots of data. What will happen to your system if the delay is introduced by the REST endpoint? How those things will behave? So all those requirements you should be able to check with fakes. Now, you should remember one thing, that most of the functional requirements you should be able to check with mocks and stubs. Fakes helps you in checking functional requirement for sure, but it can help you enormously in checking non-functional requirements, and you can run your system against fakes, okay, and see what are the non-functional parameters of your system and how difference in behavior of the endpoint or the system, the external system with which you are connecting, how the difference in behavior of them can impact the software you are writing. So these are the three most important constructs you must use while creating your unit test cases. Now, you know the constructs of unit test cases, but before I end this video, let me talk about how you should write your unit test cases. Each and every unit test case, just recall, it's independent, okay, and should be able to run within milliseconds, okay. So there is a formula of writing it called AAA: arrange, act, and assert. So here is what is the meaning of arrange. Since unit tests are independent, you need to make some arrangement. You need to start some mocks or fakes or some stubs. You need to arrange things so that the piece of code you want to test should have all the environmental constructs which is required for that particular code under test to run. Once you arrange things, you act. Act means run the code which you want to test. And assert. Assert means validate and verify the results. So each and every unit test case will have these three things: arrange, act, and assert. Okay. So this was a short introduction to unit testing, why we do it, what are the constructs of unit testing like mocks, fakes, and stubs, and how to write the unit test cases. I do hope and believe that this video was useful to all of you. Thank you all. Thanks for watching. We will meet again. Until the next time we meet, good day, goodbye. You take care.